Not sure. This is my Mariah honeypot. This thing is just listening on port 23, and it's showing as people try to attack. And this is what the Mariah honeypot net is doing. It just tries default username and passwords. There's only about 30 pairs needed to find about 100,000 vulnerable devices. And they're free for everyone to use, and even the people that exploit them can't hold them, because when you restart it, it goes back to the default password again. So if you want to take, everything is vulnerable right now. Anybody can get hit with an unstoppable flood at any moment, and all you need is like typical 14-year-old script kiddie skills to do it. Because you run this, the tool's already out there, and then you can make it do anything you want. And this is how often it's trying to find one on my honeypot. It's trying like every 1 second. Here's 2 in 1 second. So then there's a gap of 30 seconds. Then here it tries again. You know, I'm getting maybe 10 or 15 attempts per minute. So it's pretty ridiculous. Anyway, we're back to here. So there's this thing called XML entity injection, and this is very much like a lot of exploits of shell shock. Shell shock was like this. You could define an environment variable that defined a function, and then the function would run. And so what you can do with XML, XML has this command at the start that specifies external entities that are used, and typically use it to specify the format of the XML you're using. But anyway, here's the game here. So AJAX applications like Google Maps, you drag the map and it loads like just the bottom ½ inch. And so it sends a request, I just want enough data for the bottom ½ inch, and gets it. That's AJAX. And it's XML formatted data. And so the client will send a request like this, it'll post something up, and down here will be the parameters of what you're trying to get. So if this was Google Maps, it'd be a bunch of coordinates of what part of the map to load. This is a search, so it just says nothing will change in search term. This is XML structured data that's going. Then the server will reply with the answers down here. And especially things like mobile apps do this, because you really don't want to send a request and get a whole web page. You want like just one instant message or something to put on the screen. So you ask for a little bit of data, you get a little bit of data. And so you can put in these things called entity references. Let me move this iClicker thing out of the way somewhere. It's hard to move because I think it's not really a window. All right. And all right. So you can put in the doc type, you're supposed to have a reference to like the W3C website of the official document version of XHTML or whatever you're using, but instead you can define an entity. And now test ref will turn into test ref value. Anytime test ref is used, it will be replaced by that, which is harmless, but you can put other things there. So this one here will do file inclusion. Every time it sees XXE, it will then put in a system. Every time it sees system, it will put in win.int. So now the XML parser will fetch the contents of the remote file and put it in place the search term. So they defined XXE to be this thing, and it will now put the contents of that file in. So when I search, it'll say no results found for expression, and there's the contents of the file. So this is where you create a sort of meta character, which is then interpreted as pointing to something in the file system. All right. You can then connect to another server. So you define XXE to be an HTTP that goes to an address and then on port 25. So it connects to their internal web server. So this is even more fun. And by the way, the last time, 2 times back when we did a security audit of the college, we had this vulnerability. There was an open port 25 web server inside here. We're using it to send out mail that appeared to come from the White House and stuff. So all right, so now you can also use it to get information. And you can scan ports, you can do a port scan. Now you can connect to any port, you can harvest banners, and you can do denial of service. Like this one will replace the XXE with a file that is pointing to dev random, and dev random just produces an endless chain of random numbers. So it'll freeze with an ever-growing pile of garbage. So there's a simple denial of service attack like a zip bomb that expands forever. Then you can inject into SOAP. SOAP is another procedure used to send little bits of data and get a little bit of response, even more common, I think, than XML for mobile devices, but they're both heavily used. So you send a request, which is a post request, and down here it's got a bunch of parameters. So I'm going to go from this account to that account to this amount, $1,430 from one account to another, and submit equals submit. So that's a request. I want to move money across. Now what happens is that request goes to the banking infrastructure, and then it has a SOAP message that is sent to another server at the bank. Because like we were talking before, people often have to use other systems that are written in something else, and so you have like other servers. Things are bounced around across several servers, and the servers inside the company also use these same protocols. So that creates a SOAP message here, which goes from one bank server to another bank server. So you've got a SOAP envelope, and in here it's got XML formatted data. So again, from account to account. Now, what this server did is it checked to see if you have the money. And this cleared funds variable is added by the first server to say false, we don't actually have the money. So this request is going to fail because the person doesn't actually have the money. But the problem is these account numbers and stuff, even though this is going from one server to another inside your company, the parameters came from the user ultimately. So the user can inject junk into these parameters that will confuse the second order request later. And so here's some examples. There's the normal SOAP message up there. I took away the SOAP header and footer to make it smaller. So you're supposed to send from account, amount, cleared funds, and to account. That's internal to the bank. That then goes over and it will then fail. But if the original HTTP request has all this red stuff, where instead of putting an amount of 1430, I put an amount, because the problem is this HTTP request uses ampersand to separate the parameters. The less than and greater than are just characters arbitrarily used here. This is the same old problem. I can put in the meta characters that will matter to SOAP, but I'm putting them in HTTP where they are not meta characters. So I can inject stuff. So I inject 1430, then I put in amount, but I put in cleared funds true in the middle of it. And I use a comment here to get rid of this ampersand. And so all that red stuff, including this black stuff in the middle, is all the amount. So now I take that and I put that junk in for the amount and I create all this mesh, which means I now have account from amount cleared true and to account. This comment causes all this junk to be ignored and the to account is now correct. So this is a valid SOAP message that has commented out the statement that I don't have the money and put in my statement that I do have the money. And there are a bunch of these in mobile apps where you can do things like that. And pretty scary. All right, here's another one. You can also end it in an open comment tag. This is of course more likely to work because you'd really have to pretty much have a lot of knowledge about how the back-end systems work to correctly format this junk. A simpler way, like when you're doing SQL injection, you just put a comment at the end and that way you don't have to try to guess what comes after that point. You can do that here. You can start with an unmatched comment tag, and then if you're lucky, it will work because the parser is sloppy. Now, a proper professional XML parser will now fail because there's an unmatched comment tag, but some custom parsers will actually see an opening comment and then just give up at like the carriage return or something. They'll find some limit. So you might get away with that. Or if you want to find these things, if you start sticking in these XML meta characters, you're probably just going to break the syntax and get error messages. He has a few things you can try, like injecting this /foo and foo/foo. You can see this should break it because it'll be an unmatched pair. This should not break it. And if that breaks it and this doesn't, then it means they're not filtering out your extra tags. You're able to inject tags. Sometimes the parameters are stored, and then when you query the database later, they come back. This is like second order SQL injection. So in that case, you could put in a variety of these things, and you might end up having them mismatched and comment out parts of the code at random, and you might be able to see things missing from responses. Here's another one: inject the start of a comment into one parameter and the end of a comment in another parameter, and see if you can spot what's missing. Now, some big chunk of junk will be missing if they're not filtering that out. So if you want to prevent this, of course, filter data at each stage or HTL encode the meta characters. Just make this ampersand LT semicolon, GT semicolon, and so on. Then it will not be misinterpreted as a meta character at a later stage. All right. Then you can inject into backend HTTP requests. There's a few tricks here, and they're similar to ones we've done before. HTTP redirection is where I have user-controlled input that goes to a URL. So here, there's a thing called location, which points to something, and this is it's under my control. So I send a post request, and it has a location, and then I'm supposed to see the content. So I can put in for the location something that connects to port 22, and when the response will have the SSH banner stuck in it. So I can do a port scan through the server by locating some strange ports. That's using the app as a proxy. So now you can connect to other hosts on the internal network, which is pivoting. That's what you always have to do. You find one vulnerable host, you take it over. Now you have to base your attacks from there, where you can see the things that are only visible from inside the network. I can even connect back to the same server. This is one of the screwy things. Ever since Microsoft Windows Vista, a Windows machine is listening on about 20 ports above 59,000 on 127.0.0.1. There are a lot of services implemented by making a listening network port on 127.0.0.1. I don't know why people write code this way, but it is common that when they want one part of the machine to talk to another part of the same machine, they make it a network socket on 127.0.0.1, and they think it's okay because you can't reach it from outside. But you can't reach it inside, and in this case I can go back to the other ports on the same machine and I might connect to services I want to get to. Anyway, so here's HTTP parameter injection, which we played with a bit of this before, where we'd send one parameter in the get and another in the cookie and see which one wins. You can also just put multiple parameters in the get and they will override each other. So here's, again, the same thing. You're going to have from account, amount to account, and submit. But what you can do, this will then turn into on the server. It will then send this data from one machine to another inside the network. So what you can do is inject the cleared fund equal true in your original request. And now the next level will have two cleared funds parameters in the same request. And this is actually kind of an interesting thing. It's coming on one of these slides, but this is parameter pollution. Apparently the HTTP specifications do not tell you what to do if a parameter is set twice. They didn't think of this, so there are no rules, so everybody just does something at random. Some people will keep the first one, some people will keep the second one, some people will add them together somehow. So you might get away with murder this way, and I made one of these for you to play with. So let me close some of these extra windows. Here's blind command injections. We did that one, we did this one, and I think there's only 3. Yeah, that's an extra one at the end. All right, so here's HTTP parameter pollution. Here's the idea. Username Wally, password Wally. The administrator got mad at Wally for being an idiot using his name for his password. So his account is locked out. So when you click this, I'm now lockout equals 1, username equals Wally, password equals Wally. It went to 2 stages. It went to one server, which detected it was locked out and added the is lockout, and then it went here and you're locked out. Now you could of course modify it up here and that would do it, but you can also do it this way. You can put in the username of Wally and lockout equals 0. And now you log in as Wally, and you're in, and you look up here, lockout equals 1, username equals Wally, lockout equals 0, password equals Wally. My app running on Ubuntu PHP has the rule that the last one wins. So the administrator put this one in, and I put in that one, and now I'm in. So it's kind of interesting to me that this is not covered in the specs. There are no standard procedures of how to handle this. That would seem like something that would happen pretty often. Anyway, they call that HTTP parameter pollution. You specify the parameter more than once, leading to weird results. All right. So here's the one with the added parameters where they've added this cleared fund equals true in the original request, which is then causes there to be 2 attributes of cleared funds, and you might get away with it. Now, app rewriting is very common. Hackathon is all full of app rewriting, URL rewriting, where you put in something that looks like a path, but it turns into a parameter or something. This is just something people like to do. Somehow they like the way it looks better to have folders, apparently, instead of parameters. It might make sense in that script kiddies won't think of it to find SQL injection and stuff. But anyway, so here's a rule. Here's what they look like. All these Apache rules are sort of screwy like this. You've got a request. It's got A through Z. I think this is 3 to 9 characters can appear here. And if it does, they're going to be rewritten. And those characters will end up way down here at the end. So your real app is using a PHP mode equals u, name equals something. But you don't want people to see that in the URL. So you put it in where it looks like a folder at the start, and this rewrite will do this. So when they send up pub user Marcus, it will turn into mode equals u, name equals Marcus. That's all it does, but you can, of course, abuse it. So you send this request, you put in Marcus %26 mode equals edit, and now it will turn into this. The %26 is the ampersand, so it will put in the name Marcus %26 mode equals edit, which will be interpreted as another parameter called mode. So now I'm able to add another parameter I wasn't supposed to be able to handle. It was supposed to be handled somewhere else in the logic, like admin equals true or something like that. That's the game there. And then you can inject into mail. SMTP is actually a very simple protocol, even simpler than HTTP. It just has lines of text that control the email, and there's a fun attack called HTTP response splitting, where you send a web page and you put in like a whole extra HTTP header, so the reply is 2 web pages. And browsers get confused and they'll often show you just one or the other. You can create a whole different page. And so this is email splitting, what we're gonna do here. So there's somewhere on the page there's an email thing, like you can send user feedback forms. Here's a site feedback form. You put in your email address, your site problem, and the comments. The to destination is controlled by the logic of the app. So you can't supposedly send it to anyone else. The problem is they didn't filter it, but this is what it really looks like in SMTP. You have a to line, a from line, a subject, and then here's the body down here. And it's just plain text with carriage returns limiting the fields. So all you do is you put in a %0a, which is a line feed, and now I put in BCC, so now I can add another BCC line, so now I can send mail to someone else, not part of the company here, which is certainly not the intention of this. So to really go to town, I send this one. This will be site feedback foo dot. That's where now I get to put a command injection in it. I was able to change the subject of the email to be something they didn't want it to be. And to really do it right, you put in all this junk with %0a. So this will now be from the company, subject site feedback. Now I have %0d, and you can expand that out. It turns into 2 entire emails. The first one is the real feedback, and the second one is spam about Viagra, coming from their server, hitting people. And again, you have 2 whole messages here, but typically this is just going in some queue and being processed, so it'll just send 2 emails. It sends one to them and one piece of spam out. And that's very much what HTTP response splitting is like. It's and all this comes from the same fundamental issue that your first program created this text file, the next program tries to parse the text file and figure out what it means without the benefit it could have had from the first program. For example, knows this is only supposed to be 1 message and only to our administrator, but the second program doesn't know that. You give it a file and it tries to rediscover that information by parsing it, and it can get it wrong. So you're going to find these things. Try trying to attack, of course. There's 2 kinds of new lines. Windows and Linux. I think Windows is %0d, %0a, and Linux is just %0a or something like that. This is why if you open Linux files in Notepad, they look like dirt. You got to open them in WordPad. Anyway, so you got to try them both depending on what system you're exploiting. If you want to prevent these things, obviously the only thing you do is validate user supplied data. Emails, you should know what they should look like. A lot of people just make sure it hasn't added it. So I usually a.b.com everywhere they ask me for an email address. And most people will take it. They could do better than that. You could actually make sure it's got a real known email provider. Don't filter out any new lens. Don't let things get too long. If the contents are being used directly, then don't allow any lines with a single dot, because those terminate the message. And you shouldn't be allowed to terminate the message. Everything they put should be message, and only I, as the programmer, should be able to determine where the end of the message is. All right. So I got a few iClickers about that stuff. Which attack sets the same value twice? All right, I'll quit at 25. All right, and that is pollution, they call it, parameter pollution. All right. All right, which attack uses a custom doc type? There. Now it's slightly more like English. I'll quit at 25. All right, and that is XXE, XML entity. Something or other. Entity expansion or something. Is it XE or X? I think they call it XXE.
Yeah.
I don't understand what the 2 X's are. I'm just going to go back and find out. XML external entity injection. Okay, so the second X is an EX. That's rude. All right, anyway. All right. And which one uses HTML comments? While ranting, I feel like mentioning, it really is kind of evil that every language has a different comment character. That is just unnecessary. And it leads to all these problems. Anyway, all right. That's SOAP, I think. SOAP you had to put in comments to make this SOAP stuff work out. That was the red stuff here, right there. So SOAP injection, you have to have HTML comments to make it work. All right. So SOAP was B. All right.
But what was the HTTP redirection?
That is where you control the URL.
Oh, okay.
And you cause the URL to do things like a port scan or connect to the email server. All right. So let's see. I'll turn off the recorder and see who got the most right. And I'll go to the lab for a while, although I'll probably leave a bit early today. This is chapter 10, part 2.